Hello, everyone, and welcome back to OpenShift Coffee Break, part of the OpenShift TV series. I'm Andrea Ubiali, and today we have quite a crowd. We have obviously Natale, who is on the other side. This time it's going to be part of the presenters. Of course, our Fabio, and then welcome Alex, welcome Andy, welcome to our show, and I just wanted to ask you guys. I think you guys are presenting today, telling us about GitOps, and we're gonna see a really nice demo that's got a little bit of gaming in it. And then you guys presented the Summit Connect in North America. So quite a bit to show. So I don't want to take any of your time, and I would ask Andy to start today's talk.
Okay.
Let's not forget.
Go on.
Tell us a bit more about you.
Okay, I think someone wanted to say something.
No, just don't forget the main reason why we are here.
Yes,
just to show
of course. And then we say our coffee.
Let's have some coffee, of course.
Okay, I prepared the coffee. Okay, so let's start. We prepared that game, so let me share. I will start with a quick explanation on what is presented today. Can you switch to my screen?
Please, if you would just a couple of words about you, who
okay.
We know you very well, but just for the
who are you?
Okay, sure, sounds good. So I'm developer for the Quarkus team, and I prepared this demo a while ago. It was really like nothing when I started. It was just like a few car moving with Kafka and Quarkus. I wanted to present Quinoa, an extension I made for Quarkus. We may talk about that a bit later. And then it grew to something really nice that you will see later. And this is what we will present.
Okay. So you're ready to share your screen?
Yep. Okay, can you see my screen?
Yes, we can.
Can I put it? I don't think that's the command to put it big. Okay, don't know why it doesn't want to be big, but there we go. So on the right part of the screen, you can see a dashboard. And on this dashboard, you have a racetrack with two cars. Those two cars will need green energy to work. And the idea is that the energy is generated from your phones. So you just open some URL on your phone. You will have the screen that you see on the left part of the screen with a wind turbine. And by tapping really, really fast, it will generate energy. And this energy will be sent to the car, which will move on the track. There are two teams. And people will be balanced in one team or the other automatically. We don't let the user choose their name. It's also automatic for some reason that you might understand. So you will be team one or team two, and you will be able to push on the button to generate energy. Then we need to see that behind that, it's Kafka that's letting us do all this. Thanks to Kafka, let's just imagine this in the real world. We will have a farm of wind turbines. And on all those wind turbines, you will have a sensor to read how much energy is generated. And from those sensors, we will then create events that might be thousands and thousands of events per second. And with those events, we will just send them to Kafka because Kafka is really made for this kind of job. I think, Alex, do you want to explain a bit about...
Yeah, I'm going to explain the...
so let's switch. I will switch. We keep my screen, right? Okay, let's switch to this screen.
Yeah, so this is basically the architecture of the application, or how it's the application deployed. You will see, like, your mobile phone with this wind turbine there, where you will need to push really hard to generate some power. Then basically the flow is that when you open the game, you will assign it, as Andy said, a random name, and also you will assign it to team 1 or team 2. Now, this is just, synchronous call, nothing really complicated. But then it comes the complicated part, and it's like what's happened when you start generating power. So what's happened when you start, pushing just your windmill super hard right there to generate energy. Every time that you push the windmill, we're generating a REST call to our game backend. Okay, so every time that you push, we send a request to our backend, and then asynchronously our backend just sends this power to the Kafka topic. Okay, we've got a Kafka cluster there up and running, all running in OpenShift, which is it's a Kubernetes implementation. Then this event just goes from the backend to the Kafka topic, and we've got the dashboard, which is another part of the backend, which is listening all these events asynchronously. Okay, so every time that we generate power, it goes to the Kafka topic. The Kafka topic just sends this event to the dashboard. Well, actually, the dashboard consumes this event and updates the dashboard. Okay, so updates the position of the car. So as you can see, we are generating thousands of events per minute, because as much players there are, more faster you click the windmill, more events are sent to the Kafka topic. They're processed at real time and send it back to the dashboard. So this is how all the application works. So I think that we're gonna start.
Alex,
watching a
sorry
bit
for interrupting. Alex, sorry for interrupting you. Just a question: are you going to? Did you use any specific reactive framework running on Quarkus for this demo, or?
Well, we are using the the Smart Write Kafka project, which is at the end it's just some API or some reactive API for communicating with Kafka topic. That's one thing, and the other one is that let's say like Quarkus per se, although you think that it's using synchronous communication, the reality is that it's using an asynchronous communication. It's something that you as a developer will never notice, okay? But under the covers, Quarkus, if you do not specify another option, that it needs to act differently, then it will use reactive.
So by default, it uses REST Easy Reactive, which is behind the scene, making sure that the REST calls are handled reactively.
Okay.
Can you hear me?
Yes.
Yes, we can. Yes, we can.
So it's using REST Easy Reactive, and then as Alex just said, it's using the Kafka Smart Write messaging, which is sending to send and receive and subscribe to the event. And then for the connection to the UI, you can just set a flag to say you want server sent event, which lets you make sure that the event are coming from the server to the client, which is what we want to update the car on the screen.
But also there's a front end part, right? With this framework called Quinoa, and you work on this specifically, right?
Quinoa it's pretty cool. It's made to let you. So anyone who made a front end, a modern front end, will use Node.js to build it. It will be using either React or Angular or Vue. And with Quinoa, you just add your front end project in your Quarkus app, and then the extension deal with the rest. So you can have dev mode, then you can build and have your backend and front end together. You can develop on front end and backend on live coding both at the same time. We will see that just a bit later. And then you just bundle it in Quarkus, and you have everything on your cluster. So this is what we're using here.
So if I understand correctly, and again, that's the first time that I get to see what Quinoa is. Quinoa is not itself a UI framework. It's a way of integrating a JavaScript front-end UI framework with Quarkus.
Yes, that's it.
Thank you.
Okay.
Cool. So Andy, let's show this live. Today, the idea was that we have a live demo of everything from the developer workstation to production, and we all play all together this game. So the people now attending, please send your question in the chat, but also make sure to play the game. Please have your phone next to you, because this is the front end is basically for mobile phone or tablet, whatever you want to use. And then there's the backend that we will show in the dashboard. But yes, this is definitely a mobile game.
Oh, sorry. That means, Natale, that you're going to show a sort of GitOps workflow today?
Exactly, Fabio. So now Andy will start as a developer, right? Start coding and the testing locally, and then we'll show his inner loop in an environment called Developer Sandbox for OpenShift, where he can test his stuff as a developer in this free Kubernetes cloud environment. And then we move to the, let's say, prod using GitOps, and we'll show how it works with Alex as well.
Cool. Okay.
So here I'm the developer, and I created this project with Quarkus, and I want to put it on OpenShift. So the first thing I do as a developer is look on the Red Hat website and see, there is a sandbox that I can use, and it's free, which is great. And why not deploy it on it? But first, let's have a quick look at the project itself. So it's generated with Quarkus. So I just came to code.quarkus.io. From code.quarkus.io, I had added a few extensions. So Quinoa. Then you can choose, like you pick Quinoa, then you pick Kafka. Here you have the connector. So and then you have REST Easy Reactive. You pick those bunch of extensions which will help you create your app, and it will give you all the tool that you need to make sure that your app is ready to go in the cloud, which is the awesome thing about Quarkus. But let's we can go deeper into that if you have questions on this part, but the topic is more about the OpenShift part. I have this project generated here, and this is quite small, but I don't know how I can make this part bigger. When I will open the code, it will be a bit bigger. But let me talk you through it. So you have source main Java, which is a normal Java project. And then here, something special, you have a web UI directory, which is what Quinoa is actually doing. So here I have my package.
Andy, sorry to interrupt you.
Yeah.
Could you increase the font a little bit? Oh, okay. So yeah, that's
so
fine.
I don't know how to make the font of the
don't worry.
left part.
I see that the actual code has a bigger font. So
yeah, the font is big for the code, but this part I'm not sure. Maybe I know what to do. So
no, don't worry about it.
No, this is way too big. Okay, let's not do that. So here I have a directory named web UI, and just to explain, in there you have a package.json, and this is a standard UI project. It uses React. This one uses React, but it could be Angular or whatever. The most important is that it contains the package.json, and then you can by putting it here and having the extension, you can start having your UI and your backend together. Here in my backend, I have my resources for the REST, and they connect to Kafka through the configuration and everything. Let's start it locally. So just by hitting like Quarkus dev, I can start developing. While it's starting, I will explain a bit what's happening behind the scene. So this service that we're building here is not standalone. It can't work by itself per se, because it needs Kafka and it needs what's the other? Infinispan. It needs Kafka and Infinispan. So without Kafka and Infinispan, it won't start. But something great with Quarkus is that for developers, you can have your dev services started for you, which means that when I start dev mode, without having any Kafka and without Infinispan on my local machine, it will just spin them up using Docker, and everything will be plugged so I can develop easily on my machine. So see, everything is already started really fast, and I have my game running on my local machine. So if I hit the dashboard, I have the dashboard here that you saw previously, and I can start like developing on this locally. Let's see if it works. So I have this tab, I start the game, I start clicking on my turbines, it generates power, and the car is moving. Great. Everything is fine. And the cool part is that I can actually live code on this, meaning that if I go here and I just change something, I didn't really prepare that part, so this is maybe not the right time to change something, but it will just update on the UI. So in the backend, I know what to change in the front end. So I will not change anything in the backend. Besides, maybe I could add an endpoint that you can see, so we can see if it works. So let's add an endpoint here quickly. Okay, so I'm just adding an endpoint on get. No URL. I want to produce just text, and so it will be a string. Hello. Can you hear my baby crying in the background or not? Sorry about that. Okay, let's test if that works. So if I hit localhost/game, no, that's not the one. Yes, it was /game, right? Okay, and here it's this. Let's add the path so that it's on slash. Maybe I should have hello. Okay. Oh yeah, I know why. Okay, that worked. So I didn't restart the server, right? And then I will go in the UI, and as you saw, it was the V1 that we had. Let's switch to V2. So here I will enable a new feature, and if we go back here, without doing anything, it was already there. So this is what we will have in V2. Instead of tapping, it will be checking. You can check your phone. So I can develop front-end and back-end together, and this is all really quick. Let's close this. So everything is closed, and now let's deploy it to OpenShift, which is also great, because now that I've been developing, I want to go to OpenShift, which is like the normal flow you would have. First on your machine, then you push it on the cluster. I prepared here on the sandbox. I prepared a few things before the demo so that we don't do the boring stuff. So on console.redhat.com, I'm creating a Kafka instance, which is free, just for learning and everything. This is not for production. And on this manage Kafka, I created a wind turbine Kafka instance. On this wind turbine Kafka instance, I added topics. So I added game events, power, and user action, which are the topics that are used by my app. Then I
and can you increase a little bit the font
of the
browser?
Sure.
Yeah, thanks.
Is that better?
Yeah, much better. Thanks.
Okay, so let's go back to, so as I said, game events, power event, user action, and then I've been adding a few settings to make sure that I can access it from the OpenShift console, from the OpenShift cluster, sorry. I've added really open security, which means that it's what you will do on production, but for that demo, that will be all right. So that was the OpenShift stream part. Then here on the developer console, the sandbox console, you can see that some things are already ready. Let's delete this because this was just to make sure that everything was working before.
So Andy, you have two dependencies, right, that you have to put on this Kubernetes cluster, an OpenShift cluster in this case, but in general, in any Kubernetes, you need a Kafka cluster and an InfiniSpan cache. Now you show us that you can create a Kafka cluster in the cloud, and then you can connect this Kafka cluster over here, right?
Yes, that's what we'll do. Okay,
Great.
so now we are back to 0. Let's do exactly what you just said. So I will first add InfiniSpan. For this,
Can
I'm
you
using...
increase the font also here
Oh,
so
yeah.
it's more visible? Thank you.
My bad. Good. So here I'm using a Helm chart. You also have an operator for InfiniSpan, but the Helm chart was already installed here. So on the developer sandbox, you don't have the InfiniSpan operator installed. But if it was your own cluster, you would be able to use it. But here, so I'm just keeping the default, and it will install InfiniSpan for me. Let's wait a few seconds. That's really quick. And for the security part, I've set up already the Quarkus app to connect to it easily, which was like just a few lines of configuration. Now let's add Kafka. For this, I'm going to manage services. And here I have the Red Hat OpenShift stream for Kafka, which is, I already added some kind of token here, but it's really easy to connect. And then here I can see my instance that I showed just before. So here I created this instance, wind turbine, and it's here. So I'm just connecting it. And what's great is that just after doing that, see, I have my 2 services on OpenShift. So I have InfiniSpan and Kafka, which is like kind of awesome. Like in like a few seconds, I have everything ready for my service to work. Now, with Quarkus, you have an OpenShift extension, which allow you to generate the OpenShift resources needed to deploy on OpenShift, which is what I prepared. So if you look at my Quarkus configuration, I have all kind of stuff for the sandbox profile. So I'm saying, okay, for a sandbox profile, you need to generate a deployment. You need to use those certificates for HTTPS. And that's pretty much it. So it's pretty like simple stuff. But then what's great is with just those few things, when I will build, it will generate all the resources that I need for OpenShift or Kubernetes. Like all this complex stuff is done for me. And if you already used OpenShift for everything, you know that those files are the hard part to generate. Once you understand how it works, then it gets easy. But at first, this is what sometimes get a bit tricky. Okay, so I have my OpenShift file. Now let's just deploy it.
So Andy, you are using the Quarkus CLI, right? But you can use also Maven, for instance.
Yeah, that's right. So I could, just before I use Quarkus dev, but you have the exact same command which is Quarkus dev, which would have done the same. And for the build, I'm using the Quarkus CLI, but you could use Maven, clean package, and your argument.
Got it.
Okay.
Yes, so, basically with the Quarkus CLI, you abstract from the building tool. So you can use Gradle or you can use Maven, and just Quarkus CLI tool just knows what to do. So you do Quarkus dev, and then it says, okay, you're in Maven, then it automatically executes the Quarkus dev goal. Or you're in Gradle.
Yeah. Exactly. Or you can create app, you can create stuff, add extensions. So it provides you a few stuff that you don't have with the Maven command. But it just delegates to the build tool that is behind. So yeah, it will work with Gradle or whatever build tool you use. So let me explain.
Actually, with Maven, you can also add extensions. There is a special wall to add an extension.
Okay. Yeah. Okay, cool. So here you can see that I added a few parameters. So I'm telling my build that I want to deploy to Kubernetes. So it's OpenShift behind the scene, but it's using the Kubernetes API client. So it's the same, even if it's OpenShift behind. What I did before typing this command is that I logged onto my cluster with the OC, the OpenShift client, which was a normal command. So I didn't do anything special, but I will not do it live so that you don't see my credentials. And then I'm telling that I want to use the Quarkus profile, which is OpenShift Sandbox, because I can deploy this app on the OpenShift Sandbox or a real OpenShift cluster, and some stuff changed slightly. This is why I have different profile. And I'm telling that the container group is my name, because this is the project name on OpenShift.
So Andy, you could also now you are pushing to the registry inside OpenShift, but you could also push to Docker Hub or any registry, right?
That's right.
Okay.
Yeah, or Quay.
Or Quay. So this is all live demo, folks. So if, of course, it's live and everything can happen, but as you can see, those are the logs of the build. The interesting part, and is this one. So this is the front end part, right? Those assets that have been compiled. What is happening?
Here? So what's happening behind the scene is that it's building the Quarkus backend, it's building the Quarkus frontend, it's putting things together. You could decide to make it native also, because with Quarkus you can generate native app, which depending on your goal could be good. For example, if we wanted this to be in production, we could think, okay, let's have one pod which is using the Java for performance, and then let's have the pods that spin up in case of charge be native, so that they would spin up in milliseconds. So this is something we can do with Quarkus, some kind of hybrid approach between native and non-native. And here I just decided to go for JVM for now for this demo. So it's building everything, then it's creating all the resources that we saw before for OpenShift, and it's making sure everything is deployed on OpenShift. And we are done. If we go to OpenShift, see, now we have our deployment that is here. So our Quarkus application has been generated. Let's connect it to Infinispan. It was already connected to wind turbine. Normally you would have to draw this, but since I've done it before, it was already done for me. But let's make sure that everything is all right,
Yeah,
for now it's red, meaning that something.
Delete the
I will delete. Right? I will delete and create it again.
So Natale, Andrea, in the meantime, we could say that what I'm seeing is that now OpenShift is becoming more and more developer friendly compared to I'd say 2 years ago. So you have a tool, the developer console, that allows you to see
Sorry, it was running.
No, that's okay.
the demo effect,
Demo effect. So you can see the topology, something that you mainly when you start to develop microservices with a lot of components, the Infinispan, Kafka, and stuff like that. You lose the map, where I am, who is connected to what, and then from deployment perspective. Also, developers now their life is easier because Quarkus provides all the tools that allows to skip the building complexities toward OpenShift. So yes, that's become really developer friendly.
Yeah, Fabio, and what I see also is Andy didn't write it a Docker file. Andy didn't write it. Didn't wrote a YAML file for Kubernetes, so no YAML, no Docker file, just code, and that's deployed on this Kubernetes cluster. So it's I think it's amazing.
Yeah, and just a reminder, because otherwise people could tell, an OpenShift Coffee Break people. Natale and Fabio, Andrea told that you could develop everything and deploy in production. This is not a production workflow. This is just a development workflow. Then if you want to go to production, you have to do implement pipeline with Tecton, stuff like that. So.
Yeah. So everything is working. Wow. So I could actually send you the URL and you will be able
please.
To
this is a live demo.
But,
send the URL so the people in the chat
should we not wait for the on cluster later? Because
yes, we do the game on the prod cluster, but just to show that this is really live.
So you can just one important thing is that it's using a self-site certificate. So you will have to accept. I will send it the URL still, but you need to accept that it's unsafe, right?
Right. So, okay, this is the
Here.
inner loop, Andy. So we demonstrated that you, from your workstation, you used your developer workflow, then you deployed on Kubernetes. Now, let's imagine this is fine, no? This is good. Now we want to move this to prod. I think, Andy, the next step is that you as a developer or anyone should give us all those YAML files so we can use the
Right,
GitOps
that's a
approach
good idea.
to...
So if we want to do that, so that will make it real. Like I've been developing, and now let's send that to the ops, right? So I will go here. So can you still see my screen?
Yes.
So I have my beautiful app here, and I want to export it. So I just click here, which is using GitOps Primary, right? And I click Export Application, and it will start, and it will export everything from this Quarkus app, and I can just send you the zip file which is generated. So let's wait for it to be generated, and I will send you the zip file so you can continue. That's what you wanted, right?
Exactly, Andy. Now we want to move to the, let's say, prod cluster. So all your tests are great. And if you can provide the YAML file of all you've done, we can then create our GitOps repo, Alex, because now what we want to do is, as we said, we said the GitOpsify this app. We want to make it a CI part, CD part, and using the GitOps approach is a continuous deployment, continuous delivery. So now let's move it to the kind of a prod cluster. And Alex, you want to share it or I share it as you want?
Share it, and yeah.
Okay. Okay, let me start sharing the screen. So first, thanks, Andy, for this part. It's great. And thanks for providing us all the YAML file. I just wanted to say that what Andy did is, develop on this part, but then thanks to his manifest, we could create the GitOps repository. In the GitOps repository, we can share also in the chat. Let me quickly share with you in the private chat so then you can see. And in the manifest repository, we are using in this case Argo CD. So this is our Argo app pointing to this manifest, and those manifests are basically, have the deployment that Andy created and exported with that function, which is an operator called the GitOps primer, an operator that collects all the manifests and then extract them to be ready for GitOps. There's a route, there's a service, and the customization file. We're using customize here to update the version of this app. So this is the let's say prod cluster. In this prod cluster, we're using a Kafka cluster locally to the cluster. So we just deployed the Kafka using Streamzy, which is a Kafka operator to deploy Kafka in this cluster. We're using Infinispan, the same thing, and we have our application here up and running. So let's play this game, and Alex, let's play the game.
Yeah.
But before doing that, do we have to show anything else? Like, oh yes, just wanted to show that now that we are in prod, this is an AIGA available app, right? We have 5 replica, but this is also GitOps driven. So we have our Argo CD, which is controlling the GitOps manifest. And as you can see, there's the integration with this cluster with OpenShift authentication. So when you log in, then you are into the Argo CD console. This is our application. As you can see, this application in this version is up and running.
Is this Argo CD instance deployed in the same OpenShift cluster, or are you using a different OpenShift cluster?
It's in the deployment. It's in the same cluster. It's in the same cluster. So we have an Argo CD in this cluster. We have also another component which is advanced cluster security. So formerly StackRox to scan the container image representing this game. We will show after. But Alex, should we start with playing this game?
Yeah, I think that we can start, and also we'll show you up to the game all the messages that we've sent you to the Kafka topic, right? Because we want you to that you see that Kafka is your messaging solution when you want to process an amount of messages at real time.
That's great. So the app is deployed here. You can see that this app now is in this other cluster, but this is a interactive app. So I don't know how many people now connected, but just go here and please start scanning this code on your phone, or use if you Andrea, Fabio, if you can use the caption and and put this URL, because just point your phone here and click. You should see now on your phones something similar to this, like waiting for the game to start.
I'm in the same team as you.
Oh, I'm afraid. So please let us know in the chat in which team do you belong to. I'm team 1. So which team are you? This is also
and
interesting.
De Bartolo.
Show the QR code once again.
So you should refresh this, yeah.
Yes, we can see that some people is joining the race, right? And we can see team 1 has 3 people, team 2 just 1. So maybe we can wait for
just me.
Somebody else that can join the race. Come on, people in the chat, don't be shy. Just go to the QR code or the URL here, and we start playing the game. And the game, maybe for the second version, we have more people, joining it. But let's show. Okay, I think we're fine with 4 and 3 people. More people are coming. So, Alex, are we ready to go?
Yes. Well, you are 5, we are 3. Yeah, I think that we are ready. Yeah.
Yeah. So 5, 4, 3 people. The people that want to join, just just go to the URL and click on the windmill, and we can start this game. When we start the game, when I click here, you should see on your phone a windmill appearing. When that windmill appears, you just have to tap in the windmill in order to move this electrical car. This is a green game, right? So let's try it out. Are we ready, Alex?
Okay.
3.
Yes, we're ready.
2. 1. Go. Now you should see a windmill in your phone, so please tap it.
Yes.
Tap it very fast, very fast. So you start generating green energy. So of course, team 1 have more people, but let's see, team 2 is processing very good, and I think I'm doing also a good job on generating energy.
Yeah, and so people knows it's fair, because even if you 3, the objective is scaled down to compare to the team 1.
Exactly. So if the people in team 1 doesn't play, will affect all the game. And congrats to team 2. That was a great, because less people generated more energy. So congrats to you. But we have also a leaderboard, like Frails generated lots of energy. Lin Sangan, Malinger, who are you? Please tell in the chat who are you. We might send you some swag. It depends. Please tell us in the chat who are you. De Bartolo, Gaeton, Infante, Stefan, Niad. Thank you for playing it. So Alex, I think now we are in the other narrative, right? Do you want to start from here?
Yes, because at the end, we are developers, and sometimes we want to innovate, and we say, hey, I would like to just try a new way of generating green energy. So instead of, pushing a windmill, I could, for example, shake my phone. So the faster I shake my phone, the more energy I generate. So I'm the developer. I just develop all this new cool feature, and then on Friday evening, I just push the code and I just send an email to the operators and say, hey, the feature is there. It's tested. Just deploy to production.
Right.
And well, this could be a problem, because maybe I miss any parameter in the email, or maybe I just don't put it a clear instructions on how to deploy this new version, and the operator will spend all his weekend just trying to deploy my application to production, right? And this is what is known as a wall of confusion. So what we need to adopt is DevOps. And DevOps is not only about dev and ops. It's not just that dev and ops needs to work together. It's that the whole organization needs to work together hand by hand. And when I said all the organization, I mean the ops, the sec, the biz, the PO, the dev, the QA, and also the DBAs, right? And I'm not saying that the DBAs are zombies. I'm saying that the DBAs love working dev, okay? So all needs to be in the DevOps. But what's happened? DevOps is just a methodology. We need to find a way to implement it. And I think that one great way to implement DevOps is using GitOps.
Right. Thank you, Alex. I think GitOps is the right approach now to simulate this use case where we have to add a new feature. Just a quick reminder, what is GitOps? The three main pillars: Git is a single source of truth. Everything is treated as a code, and any operation is through Git workflow. In fact, also this game is made in this way. We have the first part where there's a pipeline. This is the repository of the app where Andy was working from the beginning, right? And then this generate a container image, some pipeline generate a container image and store this container image into a registry. When there is a Git workflow, a Git action like a pull request, there's also will consider the manifest describing this app. So there's the manifest repository, and there's a GitOps controller that will monitor detecting any drift, taking action, syncing any change to pushing any change to Kubernetes. So now, Alex, it's time to simulate this. What we can do is that you send me the pull request to this change. You want to enable the shaking, right? You want to enable the shaking. So again, enable the shaking is going into, as Andy showed, in the local development, going here in the web UI, changing this parameter. So Alex, if you do this live, I can approve your pull request and we can start this GitOps.
Okay. Okay, I'm going to change it then.
Let's that's cool because this is exactly what I did live, as you said, in developer mode. So I will just have pushed the pull request and you will receive it for my developer work. And this is what Alex will do. But this is like if I just push the pull request.
Exactly. From your, because you already cloned the repository, right? You forked the repository. So you tested that, and then now you wanna add this feature. Well, the best practice is fork the repo, do your change, send the pull request, then start the GitHub action. So now we want to enable the checking feature, which means
you've got the pull request.
Thank you, Alex. That means you can move your the windmill, move the car with your phone. Let me review your pull request, Alex. That looks good to me. So let me give your well-deserved +1. And now that we merge this pull request, what happens under the hood? Well, we have to kick off the CI part, right? And the CI part is automatically kicked off through a webhook that we configure. And we have a live error permission.
Restart again. Sometimes it happens. I don't know why we've got this permission denied. I think it's something related to some container and new OpenShift version. But now if you it's not necessary. Go to pipelines.
You will learn.
Just push here and rerun. And then it works.
Sorry about it. Sometimes live demos, of course.
It's time to burn some Windows XP CD.
So I wanted to show that what we did is configure a webhook, of course, here. We went into the repository, in the app repository, and we added this webhook. Of course, there's an authentication. We added this webhook. Where this webhook started? Well, this webhook started from the pipeline definition. In Tecton, you have a component called Tecton triggers. that give you the capability to add webhooks. When you use OpenShift in this prod cluster, you can even build this pipeline from the pipeline UI. So what we really did, it's creating a new pipeline, and then we added a task like, okay, I need the Git clone, and I need to add then a Maven task. So we really did this, right? So Git Maven or community Maven, whatever. And we built our pipeline, and then we add our triggers, and the triggers will give us that URL that will provide us the automation. But as you can see, the Maven build started. Now we're building the container image. This container image will be stored not in the cluster, but in an external registry. In this case, it's Quinoa. So we also added some credential here. And the last part is the manifest, the Git manifest update. We're going to update the Git manifest. Again, those manifests are in the manifest repository that you can see here.
So in the end, it's really close to what I did locally on my machine, but you automated all that, right?
Exactly. It's really close for what you did on your machine, but it's all automated. And as you can see, this already started.
Oh.
So this updated the manifest. Let's see what is happening here in Argo CD. So Argo CD is retrieving the change. Now everything is out of sync, but it will redeploy the app. And we can see this also on OpenShift, because OpenShift is doing and Kubernetes now is doing a rolling update of the app. So the new version is not available until all the health checks, so the liveness probe, the readiness probe are good to go. And this is a nice animation you have in OpenShift, so you can see when your app is really good to go, up and running.
And this is also something pretty good with Quarkus, is that all the readiness and liveness are like out of the box, so that you just make your Quarkus app and you have you install that extension for health check, and everything will work in OpenShift. And you can also like if you add Kafka, it will make sure that Kafka is started and everything, so that you are sure your Quarkus app is ready to receive requests.
Exactly, and I also want to show that what we did, it's real. So 1 minute ago we did this commit. Actually, we didn't do the pipeline. Did this commit using customize, took the hash of the container image we pushed on this registry and substituted in the manifest. So now our app should be in version 2. And since it's all live demo, let's verify this. Please go back, take your phone again and point your phone to this QR code, or just go to the URL that you find.
I see that it's asking for authorization. Are you stealing my data?
Good point, Andy. So if you are using iPhone, it will ask you to have the permission to access the sensor, because this is gonna use the sensor for enabling checking. So if you are using iPhone, please allow it. It's open source. You can see we are not doing anything weird. So just click enable checking, and now we are ready to go with version 2. The same version 2 that Andy did locally. Now we did it using the GitOps approach. It's all automated, right? Argo CD retrieved the change, redeployed everything, and Alex, we are ready to go for the second round.
Yes.
So let me go back here to our
ready for the race.
Let me refresh it. Of course, this dashboard you find in the game, it has some credential. So the people restarted joining. Let me check in which team I am this time. Fred, still team 1. So now we have 5 in team 2, 4 in team 1. If you agree, Alex, I will start the second round.
Yes, I'm prepared for playing.
So
let's go.
3, 2, 1, go. You should see the windmill, and now you have to shake your phone in this way. Please don't be careful. Don't throw your phone against your laptop.
I'm first.
Oh.
I'm so fast.
Team 2 It's going very bad, very bad. Yeah.
Again, the people that don't play in the team will affect the performance of all the teams.
You guys need to all play. Someone. Oh yeah, I need to keep generating.
Who is the Bartolo?
This is me.
Congrats to the team one. Congrats to Bartolo, Frails, Mailinger, Fullweeder, Schommer, Dyer, Lingesam, Gaiton, Bob Till, and Stefaniet. Andy, where did you find all those random names? Just a question.
So that's a good question. So I went on some GitHub repository which was generating like first name and last name, and I just took the last name part.
Oh, that's great. And people in the chat, please share in the chat who were you. It's nice to see if you enjoyed and played this game. But what we wanted to show you is this. We did this change Friday afternoon. Just a comment, pull request, everything is automated, and we have version 2. The good thing of Argo CD and OpenShift GitOps, you can roll back to the previous version. If everything is wrong, it's just one commit away, right? And we're not finished yet. We wanted to show that in this demo app, we also insert this advanced classes security for Kubernetes. The upstream name is StackRocks. We wanted to show that we had also a scan of our container image. We have some scoring of the scan. There's some CVE in this image, talking about production, right? We can decide if not to let this go to prod. So the pipeline can really stop if we say that our risk priority is too high or we have too many important severities CVE. We can decide to block this. But for the sake of this demo, we decided it was good to go. But this is also interesting to understand. Maybe we can control the Docker file. Maybe we can control how we build the container image. Just to mention it. And Alex, just to finish, I think we can show some of the messages in Kafka, right?
Yeah.
Can you drive me to the? So it's one of the.
Yeah, you can just it's just one of the pods. You just select one of the pods. Then you go to terminal because at the end you can access to a container using this button, and then go to the bin directory and run the following command. There is a binary or a shell script there that it's like as Kafka console consumer.sh.
Oh, yes, maybe I have it here, Alex.
Yeah, if you got it there somewhere, you can just
in my notes. Yeah. So if I run this command, can you explain what is this command about?
Yeah, this command basically it starts. This one
listing the topic that we have on right,
and that is consuming all the events that we've generated. You see that there is a lot of them. All these are events that we
I saw myself
generated. When I push the windmill, you generate one event. This is the event that is stored inside the Kafka topic, and you see that there are a lot of them.
Okay, so each time I tap on the windmill or shake the phone, this is a Kafka event.
Yeah.
So every time
we can see when you tap, it always generates in 30, but when you actually check, it depends on how much you check.
Okay.
It goes between 0 and 100.
Well, that's interesting. And what about InfiniSpan? What is the usage of InfiniSpan in this case?
So InfiniSpan, so as we said, we have multiple pods, and we need to make sure that everything is consistent for the user. So when we assign user and team, we need to make sure that the number of people in team 1 and team 2 are balanced. And for this, we need a shared counter, a cluster counter. And also we need to make sure that the user are unique, the usernames. And this is why we use that. But you can use InfiniSpan also for caching or for, it depends on what you want, but there are a few atomic operations which are really great for what we wanted right here.
Fantastic. So just wanted to show that we were able to do a nice, mobile game in architecture, front end, back end, using the streaming, data streaming events, caching or session and keeping, and then Kafka messages, distributed streaming. Then we were able to use pipeline using Tecton. We were able to use GitOps using Argo CD. It was all made from the inner loop that Andy did to this outer loop that we implemented in this OpenShift cluster. I stopped sharing the screen, but I think this is really, really cool. What do you think about, folks?
Yeah, as I told before, definitely yes. So this demo showed clearly how concrete development workflow could be implemented on OpenShift using tools that are very easy to manage, and actually you could really implement a true GitOps best practices, leveraging all these stuffs, and that's great. It's just not theory. You can really do it now, avoiding to manage, as you told before, a lot of YAML, which are obviously
if you take like something I really noticed, I'm more a developer than an ops. I'm developing, so OpenShift, I just use it to try my stuff. And I went to OpenShift a few years ago, and I was like, wow, that's way too hard. And now, like without touching anything like complex from OpenShift, I managed to do everything I needed. And like I'm not an ops, but I did some ops stuff as a developer, which is kind of great.
Definitely, yes.
So what is the best practice? So it all starts with the idea of a developer, and the developer starts working with their own resources, and sometimes they then use a sandbox of OpenShift. Who creates the Argo CD application that somewhat will then be able to put under control the via webhooks the changes that are pushed into the GitOps, the Git repo for the config? Is it a collaboration between a developer and an operations person? How is that a joint team in a sense?
I think it's a collaboration, Andrea, but also, moreover, in OpenShift, it's self-serve, because from the pipeline UI builder, you can build the pipeline on your own. From Argo CD, you can create an Argo app from the UI. So, you can do the complete loop alone as a developer, but this is sure a collaboration between the developers and the DevOps, or now platform engineers, that need to prepare the production with everything set. Like we show advanced cluster security for Kubernetes. Maybe you want to block that pipeline if the security scan is not and the score is not enough, right? So I think it's definitely a collaboration, but the experience is so nicely done that can be all self-serve in the cluster, to be honest.
And I guess.
And Alex and Andy, you are also developers. You can say that, for instance, Alex is a GitOps developer today, so you can share the same comments.
I think from my small experience, it depends mainly on the also level of security that a company could have inside. So if you have to be compliant with some very strict security rule, probably you can leave more freedom to the developer or not, depending on that.
Well, yeah, but you know that with DevOps, right, it's more that you build it, you deploy it. Well, you develop it, you build it, you deploy it, right? That's the.
Let's call time.
It should work.
Yes, I think that's all we have time for today, I guess. And Gatale?
No, as a wrap up, I just wanted to say that we showed a nice GitOps game, and we say that DBA are zombies. This is just a wrap up of the
I wasn't sure they were zombies or Frankensteins. I wasn't quite sure what the icon was.
Joking.
Okay, so see you next session. See you. Thanks a lot.
Thank you, guys.
Demo.
Thank you all.
Cheers.
Thank
bye
you.
bye.
Bye bye.
Bye.